We are skipping the sections in between here. We're just jumping to section 5.10, and we're going to talk about ionic charge. And this is where we see some patterns in the periodic table as well. Most of the main group elements form their charge when they make an ion based on how far their group is from the noble gases. And a simplistic way of explaining this is they want to have the same number of electrons as the nearest noble gas. When an atom forms an ion, the number of protons do not change. The proton is the identity of the element. And so the number of protons can't change, but the number of electrons can change. And if we have different numbers of electrons and protons, negative and positive charges, then overall that atom becomes charged. It could be charged negative or positive, and that's what we call an ion. So they're going to gain or lose electrons so that they have the same number as the noble gases. And I have this imaginary place that I call Mrs. K's Chemistry Land. It's a happy place for me. You know, Disneyland is the happiest place on earth. I'm not going to say that my chemistry land is the happiest place on earth, but sometimes it's happier than real life. So I may refer to chemistry land occasionally. So in chemistry land, the noble gases are like those really cool kids in high school, that in crowd, that everybody was trying to be like. Did you have people like that in your high school? Maybe not everybody wanted to be like them, but there was this group that was in, and other people wanted to be like them. And so they copy their clothing, right? They dress like them, and they wear their makeup like them, and they do their hair like them, right? They want to look like the cool kids. That's what these elements are doing. They're trying to look like the noble gases. They can't become a noble gas. You can't change who you are, but you can change what you look like, and you can change your clothing. And I think of the electrons, because they're on the outside of the atom, as being a little bit like the clothing of the atom. They can change that, so they can change the number of electrons. Metals tend to lose electrons. When they lose electrons, they become cations. And nonmetals gain electrons and become anions. So let's just think about maybe sodium. Sodium is a metal. How many protons does sodium have? It's the number above Na on the periodic table. 11, right? It has 11 protons, and those have plus charges. And the atom has how many electrons? 11 electrons. And the electrons have negative charges. So we have plus 11 and minus 11, and that adds up to 0, right? What if we lose an electron? It's still it's still, and then you change it. No, that's not right. That's group number 4. 11 protons. If we lose an electron, now we've got 10 electrons. How many electrons does neon have? 10. Neon's a noble gas. If sodium loses an electron, it has the same number of electrons as neon. And in sodium's book, that's a good thing. So that would be 11 positive charges plus 10 negative charges. What does that add up to? It adds up to plus 1. So sodium then is a plus 1 ion when it does that. So the metals tend to do that. They will lose electrons, and when they do that, they gain a positive charge. The nonmetals do the opposite. We'll see a lot of things where the metals and the nonmetals kind of act opposite to each other. In chemistry land, the metals are masculine and the nonmetals are non-masculine, feminine. They're girls and guys, okay? So the nonmetals do things differently. They gain electrons. If you're adding more negative charges in, then you have a negative charge. Another way to remember this is nonmetal starts with N and negative starts with N. Nonmetals form negative ions. Hydrogen, again, is an exception to many patterns, and he's an exception to this as well. Let's look at the ones that are not exceptions. Over here, we see the group 1A metals, And they're all going to form +1 ions. They're in group 1, they form a +1 ion. The group 2 metals form +2 ions. And over here, aluminum is in group 3, he forms a +3 ion. There's a relationship there, isn't there? Group 1 +1, group 2 +2, group 3 +3. And it has to do with how far are these guys from the nearest noble gas. Really, this is more like a spiral. We should take this as a piece of paper and bend it around on itself, and then it would make a cylinder. And so lithium, by losing 1 electron, goes around the back of the cylinder and looks like helium. Sodium loses 1 electron, going around the back, has the same number of electrons as neon. For magnesium, magnesium has to lose 2 electrons to do that. So if it lost 1, it would have the same number as sodium, and by losing 2, it has the same number as neon. Aluminum over here would lose 3. Now, the transition elements, these metals, those are very unpredictable. Those guys are unpredictable. So we're not going to worry about them. Let's look at the nonmetals. So here's fluorine. How many electrons does fluorine have? 9. It has 9. It would like to be like neon with 10. If it gains 1 electron, it becomes like neon. So it will gain 1 and have a -1 charge. Oxygen needs to gain 2 to become like neon. Nitrogen needs to gain 3. And so I think the most straightforward way to remember these charges, because you're going to need to do that, is pretend you're playing a board game, and you're going to put your marker here, and if you want to know what charge phosphorus has, you're going to go in the row that phosphorus is in, and you're going to start at the far right side, and you're going to count backwards. Counting backwards is negative. This is 0, -1, -2, -3. And that works for all of these nonmetals. Selenium, you start over here, -1, -2. Iodine, 0, -1. So we can predict the charges of these anions, these nonmetal ions, just by where they are in the periodic table. And these particular, the group 1A, 2A, and 3A, we can predict the cations, the metal ions, just by their position in the periodic table.